Hey, good day, everyone. Thanks for joining us for Programmers Week. For those of you who don't know me, my name is Vincent Bortone. I'm a technical manager here at Cognizant Softvision, where I manage teams and architect enterprise solutions. I've been with the company for about 3 years now. Today, I am excited to talk to you about distributed systems, especially with Dapper. And I encourage everyone to share your questions in the chat, and we will answer those at the end of the presentation. So without further anticipation, let's get started. So first things first. So Dapper does not equal Dapper. So in talking with a lot of my colleagues over the last couple of weeks, talking about my presentation, I noticed that people immediately sort of gravitated towards Dapper, the ORM. And so I just wanted to clearly let everyone know that we are not speaking about that product today. For those who don't know who that is, what that is an ORM, sort of like entity framework designed by the Stack Overflow team. Essentially, it's what drives Stack Overflow. And it's a great system, but it is not the topic today. So today, we're going to talk about Dapper, which is a distributed application platform to help assist in developing microservices. But before we talk about Dapper, let's talk a little bit about microservices. Now, I'm sure most of you are familiar sort of with the basic concepts of microservices, but I just kind of wanted to go over some of sort of like the benefits and some of the challenges of building microservices. And hopefully that will lead into sort of why and what Dapper is and why Dapper can be so useful in this scenario. So first off, microservices, their goal is to be independently deployable and scalable, right? So you want to make sure usually they're designed with their own code base. They have their own CI/CD pipelines, and they're really designed to sort of really be their own true entities and with their own teams. You may be familiar, or you may have heard of the two pizza team rule, or the two pizza team, where the size of a good microservice team is usually around large enough that two pizzas would be able to feed them. I guess depends on how hungry everyone is, but so that is the first tenet of a good microservice, right? The second would be fault isolation, right? So if you have a specific microservice and a microservice fails, that the rest of your application does not fail. That also goes back to sort of that independence. And being able to sort of, run each component in an isolated manner. And finally, we have the smaller code bases, right? So again, the sort of the micro in microservices, we like to be able to have very distinct areas of functionality and with very distinct purposes. So with all those benefits, let's talk a little bit about some of the challenges of developing microservices. First off, there's this concept, there's the complex communication, in a sort of a traditional development platform where you have, the term everyone uses today is monolith or monolithic application. Everything is essentially usually running in the same process on the same server. It's very easy for your different components to communicate with each other. But when you get to a microservice level where each application or each component of the application's microservice sits in its own process, right? Whether that be on one machine or multiple machines, in the cloud, in clusters, Kubernetes, they are independent entities, and communicating between them requires different patterns and different approaches. Second, debugging and integration tests. Along the same line, now that you have an application that has 5 or 6 running components, maybe 8 or 10, or if you're Netflix, 100, 1,000 different microservices that are constantly in communication with each other, now you're adding a lot more factors. You're talking about network and network latency and issues of, again, back to, things are fault and fault tolerance, and how to resolve that and be able to keep the application running even when certain components are not. So, and then finally, there's this idea of interface control, right? So where each microservice essentially manages its own API interface, and understanding that other systems that one component may not know about, those components, there's essentially this idea of a contract, right? Where microservice A needs to talk to microservice B and expects that microservice B is complying with their contract. And if their contract for some reason needs to change, there's complications around that. We get into the whole idea of versioning and supporting and keeping certain interfaces standard, and things that come up in even let's say in the .NET world, with C# and using interfaces in there and sort of essentially staying on or respecting the contract you design. For those of you who've been around for a long time, you might remember if you've ever done any COM development in Windows, you remember that interfaces were a lot trickier back then. If you're doing them in Visual Basic or C++, they were the rules were much more rigid, and hence if you remember the term DLL hell was essentially usually involved when DLLs did not properly maintain or respect the interfaces that they proposed they did. So let's move on to here. So finally, we could all agree based on sort of the pros and the cons that getting into microservices, there's a high barrier of entry, right? So while there's a lot of great aspects to it, those challenges are real and can cause a serious sort of impact in the time of development and release. So that brings us to Dapper. So Dapper is lowering the barrier of entry, as I put it. So Dapper is a distributed application runtime. You can think of it helps developers build event-driven, resilient, distributed applications. These applications are primarily microservices. It will help you. Dapper will help you tackle the challenges that come with building microservices. At the same time, they kind of keep your code platform agnostic, and we'll get into that in a second. So Dapper it's actually a portable runtime. It runs alongside your code, and the way you design your code is that your application, your microservice, will perform a lot of its interactions directly with this Dapper side component. So let's move on to sort of some of the projects. So the main goal of Dapper, right, according to the Dapper team, is right, any language, any framework, anywhere, right? And so Dapper is designed, because it's its own isolated process, it can run with pretty much every popular language and framework. Today, we're going to be talking about .NET, but we could just as easily be talking about a Node.js microservice written with Express, or a Python microservice written with Flask. We are, again, that level of agnosticness is a real draw, a real benefit of Dapper. As you can see sort of in the middle of the screen, so what Dapper actually offers is they offer these, what we call building blocks, which we're going to get to in more detail in a second. These building blocks are essentially abstract a lot of common needs of microservices, essentially any application, right? So we have secrets management, we have pub sub, we have state management, essentially, and we have sort of this idea of service to service invocation. And today, when we get to the demo, I will be demonstrating the first three items on the list here. I'll be demonstrating the service to service, state management, and pub sub, but we'll talk briefly through all these items in a second. So on that note, let's get into the concepts. As I just mentioned, we have these sort of 7 building blocks, right? So, your service to service invocation would be, how does microservice A talk directly to microservice B, and how to do that in such a way that A doesn't necessarily need a lot of configuration information about B. That environment information can be provided either locally, as we'll do today, or through the Kubernetes cluster, and how these components can sort of work together. State management, essentially exactly how services maintain and store their data and state information during their sort of while they're running, and as well as durable state. Then of course PubSub, really sort of the more preferred way of services talking to each other, right? It's sort of best practices today. If you happen to catch Rocky Laka's keynote this afternoon, he talked a lot about asynchronous messaging, and it really comes down to sort of when you're designing microservices, you're designing these type of distributed systems, best practices sort of dictate that you want to sort of work in this messaging concept. Bindings are essentially endpoints you can think of. If anyone here has ever worked with Azure functions, you'd be very familiar with the binding concept, right? So again, sort of either triggers or outputs or connections to external systems. And we'll go into that a little bit more. And of course, we have actor model. I won't go into too deep. An actor model would take all day to talk about. So we'll just cover that very briefly. Observability, that is also the essentially the tracking, telemetry, metrics, being able to measure how things are working, uptime, health, and then finally secrets, right? Of course, any good application model, you want to make sure that you're not storing sensitive data, sensitive connection strings, things of that nature, and a sort of a secrets module sort of abstracts out. And I guess before the next slide, I use the term abstraction, and abstraction is really sort of one of the driving factors here, right? So as you're going to see when we go into the building blocks and then sort of what drives the building blocks, just keep in mind the concept of abstraction and sort of the power of abstraction. Today, if you work in object-oriented programmer, this is a .NET talk, so a good chance you're quite familiar. You've worked with .NET for a while, and you're familiar with object-oriented programming. That abstraction of work into objects is a very important part of what we do, and so so just keep that in mind. And let's move over to the next slide. So a sidecar, right? So I've thrown this term around a little bit. If you're not familiar with the term, the sidecar comes from if you've ever seen a motorcycle with a little car on the side of it carrying an extra passenger, technically that would be a sidecar, right? So that's kind of where the name comes from. But as you can see from this diagram here, and as you'll see from the sample code in the demo, is that you design your microservices to work purely with the sidecar, right? And the sidecar, because it's its own process, can be invoked either by HTTP or by gRPC, but it provides these endpoints, as you see sort of on the bottom of the screen, for the different building blocks that we discussed. And just a side note, sort of the actual Dapper runtime is actually written in Golang, right? So the truth is you don't need any Golang experience or knowledge to work with it. It just happens to be that's the language of choice for building these out, for building out the Dapper framework. And like I mentioned in the earlier slide, we really want to be language or platform agnostic when interacting with this. Right. So Dapper can be hosted in essentially two different models, right? So you have, for developers developing locally, you have this self-hosted model, right? And that is what I'm going to show you today in the development, in the demo portion of this presentation. As you can see here that, your microservice essentially is paired, each microservice is paired with its own instance of Dapper, and it's the actual Dapper instances that talk to each other. And again, we'll get to that in a sec. And now, as we sort of move on here, here's sort of an example of what sort of how Dapper would live in a more production system, right? There is a heavy sort of emphasis on Kubernetes here. Like I will not be covering Kubernetes too much today. We won't be deploying there, but definitely keep in mind that when you're seeing Dapper and you're seeing these examples, you probably want to think, in a production environment, how these services are going to be hosted and how they're going to communicate with each other. Think of this image, keep this image in the back of your mind, as far as sort of like what the end result would be. So like I mentioned earlier, we have SDKs and frameworks, so alongside purely talking via HTTP or via gRPC, the Dapper team has provided a ton of SDKs. We have .NET, of course, which we'll go over today, JavaScript, C++, Python, Rust. Also, the Dapper team has been working to integrate with other systems. When I talked about bindings, we talked about, here we see I have Azure Functions, integration with Azure Logic Apps. We have Azure API Management, and then Keto, which is a Apache Kafka event scaler, essentially, and then finally, of course, the Visual Studio Code and some of the development tools, and we'll see some of that today. So I also mentioned monitoring and observability. So Dapper is designed with the sort of telemetry in mind. At the sort of the end of the demo, time allowing, we'll hopefully be able to show the aggregation and sort of some of the benefit of how Dapper sort of admits telemetry data and how we can centralize that and collect that very simply. Also here, Dapper also has its own monitoring service. I'll show that briefly, hopefully today too, as part of the demo. So here, so let's now focus in a little bit more on the Dapper building blocks. All right, so what exactly is a Dapper building block? So, at its core, a building block is, essentially this API endpoint, like we saw earlier, and it encompasses one or more components. And components are essentially the, abstraction that allow that particular building block to connect to real physical sources, right? So here is just sort of essentially we have a list of 6 types of components, starting with state stores. So as you can imagine, the state storage, like some of your favorites will be here. Cosmos DB in the cloud, Amazon's equivalent. Of course, locally, we have also Redis, MongoDB. Today, I'm going to be demonstrating my examples with Redis, but you can also SQL Server, service discovery, right? These components, this includes sort of a MTLS for encryption communication between different services. MDNS is a protocol, being able to essentially look up services that are defined by these components. Go through this list quickly. Pub sub. We will, of course, also today we'll be using Redis as the pub sub provider, but this could just as easily be swapped out with Azure Service Bus, RabbitMQ, Azure Event Grid, I believe Apache Kafka, and so on. The bindings, of course, like we talked earlier, and then of course secret stores, right? So Azure Key Vault, HashiCorp Vault, and there's a couple more in there as well. So let's jump right into the first, actually, I think, yes, we lost one there. Here we go. Sorry. Service invocation, right? So the first example of a building block is sort of how you can have service A talk to service B. And this diagram, and we could debate, and I will debate at the end about sort of how important or unimportant service invocation is, but this is a good diagram as far as sort of like how Dapper works in general. Right. So imagine you have the 2 microservices, service A and service B, right? So service A, starts off, that service A makes a call to Dapper, and that's either an HTTP call or a gRPC call. Right? That call is then forwarded to the appropriate service or service B in this case, and by utilizing that name resolution component, right? So that, as I discussed earlier, is sort of how Dapper resolves the other Dapper instances in the cluster, and then is able to communicate and communicate between them. Right? So, as that call, once the name resolution is made and gets the appropriate IP address and port, then that call will be forwarded to the Dapper sidecar on service B, which will then, of course, forward the message to service B and then sort of make its way back around, right? So the service invocation again is very much like an RPC style. You're calling in and you're making that remote call from A to B, and so the next building block is state management, right? So here we have an example of storing key value pairs in Redis. Again, like I mentioned, this could be Cosmos DB, it could be SQL Server. But again, the abstraction, right? As you can see, and I'll show you sort of the configuration of components during the demo, that remember that your service A, doesn't need to switch anything when it talks, when it moves from, let's say Redis to Cosmos DB, right? So this level of abstractions is very similar to the argument that an ORM makes, right? That, code to entity framework, and, if you need to switch from SQL Server to Oracle, it should be minimal work. Now, we all know that's usually not exactly the case, but, again, the driving goal here is to is to simplify the developer's life. And so, and we'll show state management a bit shortly in the demo. And okay, so what I would say is more important is sort of the publish subscribe communication, right? So as I mentioned earlier, Dapper also abstracts out the individual complexities of each of these sort of components, right? So in this case here, we're showing Redis, we're showing Azure Service Bus, whichever component you configure, the interaction with the pub sub mechanism is the same. So again, the same thing: abstraction of the underlying technology from your development experience and your own developer implementation. And as you can see here is just another example. We go in a little bit, sort of an example of what publishing would look like. Internally, your service will, when using an SDK. Behind the scenes, again, you will be making that HTTP or that gRPC call to a particular endpoint. That endpoint will then handle the publishing of that message to the component or the sort of service bus of choice. And then, of course, at the same time, all those other components have registered themselves with the bus as subscribers and will handle the event as necessary. And again, we'll demo that shortly. All right, so bindings, just brief review again. So bindings are sort of like our external, how do we respond to external events outside our cluster, outside our service that can be then dealt with, right? And so this very much, again, is, if you actually saw my Programmers Week talk last year, we talked a bit about using, the talk was on using Azure Functions as lightweight microservices, right? And this is that same concept, and very much falls in line with the serverless world, where you're very discrete pieces of code. In this case, your microservice would just be a very discrete piece of code that handles a particular event, does what it needs to do, and then sends it off to the next step, right? Whatever that output binding be, whether it be storage or another event queue or so on. Here is an example of sort of secrets management in the same mannerism as the other building blocks. The application will talk to the Dapper sidecar, and the Dapper sidecar, again, configured with the appropriate components, will use the appropriate secrets vaults to sort of manage storage and retrieval of secrets. All right, and then the final two, we talked a little bit about observability, and we'll go into the demo. And then actors, if you're familiar with the virtual actor model, essentially there is an implementation of the virtual actor model. From what I hear here, is very similar to the implementation that comes out of Microsoft Orleans, if you remember that project, which is actually where I think a lot of the Azure Functions underlying design, at least, is heavily inspired by that project. And if you remember Microsoft Service Mesh, that also it was sort of a derivative of that Orleans project. All right, so before we get, and we're getting close to the demo now, and so before we get to the demo, I want to talk about another product. Now, when I was putting together this presentation, I was, I essentially was running the Dapper containers by hand, and essentially the development experience is not difficult, but it is a little, I would say laborious, but you're essentially invoking your microservice through a call to Dapper, so Dapper can run the sidecar alongside it, and it's not the most intuitive or sort of rapid development experience. So, in my sort of research for this talk today, I came across another project, Project Tie, and the project, and you'll see us using a lot of this today in the demo. It really came out to be so important that I really felt it deserved a little bit of description on its own. There was a great talk earlier today specifically on this topic, and we won't go into as much detail about Tie during today's talk here, but I definitely would say Tie is definitely something that you want to look at. It's what Microsoft is calling an experimental project, right? So even to install it, the NuGet packages are, they're only in preview still. You remember to check that flag in Visual Studio before you install them in your project. But what Tie does is, to me, the best way to describe Tie is like, it is a very .NET friendly version of Docker Compose, right? Where you take your by itself, you could just use it from the command line, and it'll scan a solution file, and it will appropriately launch all your microservices and help with some of the configuration of any type of service. But what's really cool is that Tie has some great support for Dapper, and we'll go through that in the demo. But it makes sort of the running, the management, and the debugging of microservices so much easier. So a lot of what today's demo, the capabilities that we're going to show, a lot of that has to be actually, the credit needs to go to the Project Tie team. Very interesting project. Again, like I said, Microsoft it is on GitHub. It is an open source project under the Microsoft domain, but it is definitely something I recommend checking out, and definitely check out from earlier today's presentation on Project Tie to learn some more. And on that note, we are going to jump into the demo. So today's demo is going to be a sort of very lightweight introduction via what we call it, a rideshare app, right? So, I thought we probably had enough of shopping carts and orders, so I thought we'd try something a little bit different for the demo. So today our demo is going to essentially use 3 services. The API gateway and the app don't exist, so we're going to be focused really in on that inner box, the microservices, and as well as some of the Azure interaction. Viber, I just thought was funny. So instead of it's like Uber with a V. So excuse me, that didn't share properly. So let me just stop sharing my screen for a second and go into sharing my desktop. Okay. Okay, where my Zoom controls went. There we go. Okay, so I'm going to share my entire desktop now. There we go. Thank you for that. Sorry, just sort of close this. All right, so let's start in Visual Studio. Let me just get the zoom up on here so it's easier to read. Okay, All right, so here we have an example of a .NET solution today. So let me step back for a second. So today we're going to use Visual Studio Code for examples. Visual Studio, both the Dapper team and the Project Thai team have provided some integration, some plugins for Visual Studio Code, and sort of the official plugins for these projects are sort of live or provided for Visual Studio Code. I will say for Project Thai, there is an unofficial plugin for Visual Studio 2019 that also works very well. There is also, even for JetBrains Writer, which funny enough was how I originally started this code base. But I didn't get a chance to test that with the Project Thai, but there's definitely a couple options for the editor of your choice. So as we look at the left here, we're going to sort of move along and just sort of look at our solution here. So right off the bat, you'll see, essentially we have 3 projects here. We have sort of our user service, right? This is what will look up the user. Order ride services is like our main entry point, right? So creating a new ride, and then the driver location service, which would essentially find the closest driver to the address that you're submitting and return that driver to the user. So of course, in sort of true demo fashion, these are very much contrived examples, but if we just expand one of the projects here, what you'll see is that each of these projects are just plain web API projects. This is I'm running this .NET 5, but this probably would also work fine with a .NET Core 3.1, and I imagine they'll easily work in 6 in the very short future. And what we have, and again, each service. The Docker files, I added those when I created them, not required for the development process here. And then, as we go through the controllers, as we can see here, we have our API controller. For anyone working in ASP Web API, this should look quite familiar to you. And this is where some of the .NET specific SDK features come in, right? So right off the bat, we have a NuGet package, which has a Dapper client, right? So the Dapper client is handling a lot of that functionality that, I'm gonna actually zoom it out one level, that handles a lot of that HTTP/gRPC functionality you saw in the diagrams earlier. We are, and gives you a more traditional .NET development experience. But one of the really cool items is sort of how you can use, you can leverage these specific Dapper attributes to decorate or action methods and controllers. And so what you see here, this is our, we're in the driver controller. This is, after a request is submitted, and we'll debug and go through this in a second. But this actual call, this actual method can be called by 2 ways, right? So it is a web API, can be called through an HTTP endpoint and the ride create endpoint, but also by marking with the topic. This action method now responds to the pub sub messages that we've sort of specified. And that's probably a good time to switch over really briefly to components. So we talked about component definition earlier, right? So all these building blocks essentially use components to do their work. And as you can see here in our solution, we're at the same level or the solution level, we have a folder here called components. And for each major building block, and like I said, in this case, we're using, we're using 2 here today, which is the pub sub and the state store. We've configured these 2 to, and this is how we configure them, I should say, right? So, it's this file that defines a couple of the environmental variables, right? So when we go back to that driver controller, you can see that, we're telling this API to listen on this bus, which is called message bus, and listen for this topic, right, which is ride created. The configuration of message bus occurs here in the pub sub component. And so, you could have more than one pub sub component. You could have obviously different types of providers for the component, and this comes back to those different stores. So today, like I mentioned, we're going to leverage Redis to act as our pub sub platform. And you can see here, just a simple YAML file that just defines some basic Redis information. In this case, this is a container that's running on my machine. And I'll show you my Docker desktop in a second. At the same point, we're also defining a state store. We're using the term default. You'll see it in the code when we specify, sort of the storage engine. And again, today I'm using Redis, but we could just as easily swap out. And actually, I'll show you. Unfortunately, this was not ready for the demo, but here is an example of swapping out the state store with moving it from Redis to Cosmos DB. So I have a Cosmos DB emulator local on my machine, which is why I'm not so worried about sharing the key with everybody. But we, with just changing out the component and then restarting the application, you now can start, switch your store over. And that goes back again to that driving thought of abstraction, right? Getting building an application and building your application really just to concentrate on the business needs and the important, and leaving the plumbing and all the pipe work, to this platform. So at that point, let me switch over now. Excuse me, I'm going to close that out. Sorry. Let's move over to the console, right? Okay, so before the beginning of the presentation, I went ahead and I ran the tie tool, right? So actually, before we get into this, let me just show you one more file. So one more YAML file to sort of go over. So this is the actual tie configuration. Now, I mentioned earlier that tie could be used to, could scan your solution directly. However, if you really want, to get the most flexibility and configuration, you want to define a tie YAML file, right? And especially with Dapper, we have to use the YAML file. And this YAML file, as we scroll down it, might feel familiar, especially when we get down to the services. This is starting to look a little bit like a Docker Compose file. Now, I'm using the very bare minimum here, and that's one of the beauties of the project tie, is that it's going to handle all the port generation for me, and I'm going to show you a dashboard now in a second that sort of ties all this together. So and of course here we specifying the components path because, as I said earlier, tie has support for Dapper. So in order to get that Dapper support, we need to have that Dapper section in the configuration file. So that being said, let's now move. As I mentioned, all you need to do to get your application running, essentially run every project in that solution, or at least in this definition, to be more specific, you just go to command prompt and you run tie run. And at that point, essentially it launches Docker and creates essentially a ton of different container instances for your services. What you'll see is that essentially each service has its own container. And alongside that, each instance of Dapper has its own container. And it's a one-to-one relationship. As we saw in the diagrams earlier, each service needs its own instance of Dapper in order to properly work. So let's move over to this browser here. Let me just expand it full screen. And so I have a couple of windows open here. So this is the dashboard. Let me just refresh it here. So one of the things is that every time it runs without, unless you specify the ports, it will always sort of dynamically generate new ports or run in on different ports. But as you can see here, Ty has gone ahead and we have 7 containers sort of managed by Ty right now, Project Ty. We have the 3 services and the 3 Dapper sidecars. And to prove that these services are just simple web API projects, what we're going to do is I'm actually going to go ahead and I'm going to launch this one here. You're getting a 404, but if you're familiar with web API, you'll know that the index or the root delivers a 404 for web API. So what we need to do is specify. However, what I do have here is I do have a Swagger file for each one. So here we have our order ride service. This is our entry point. You can come in, and even though that in this particular case, this API is designed to be instigated from a HTTP call, other calls can be, will essentially also be managed or sort of invoked by the service bus, which when we go through the debugger now, we will show that. So, but just to prove out a point here, let me just go back to the dashboard really quick and go to the user service, and the same thing here. Oh, sorry. Okay. Okay, so here, so part of our workflow was to get that user ID. So I am going to, in good Swagger fashion, let me just copy the GUID and run it here. And we get back our results. So as you can see, we can independently interact with our service. In this case, we're just doing an HTTP call. But of course, that's not as interesting, right? So what we're going to do now is we're going to sort of simulate sort of that order creation process. So in order to do that, what I want to do is I want to go back to Visual Studio Code. And what you'll see here is I have a couple of, I've got a lot of plugins on the side here, but the one in particular I'm interested in is this one here, this knot, right? So this is the Ty plugin for Visual Studio Code, sort of the official plugin for the project Ty. And what you see here is that this plugin sees that Ty is running and sees the actual services that are running. And it's smart enough to know that things like Dapper and stuff like that are sort of auxiliary services. But what we're going to do is we're actually going to come in and we're going to attach our debugger in Visual Studio Code to multiple services. And the way to do that is we just click on this little bug guy here, and we're going to do that for order ride service. And we're also going to do that for user service. Okay, so let's go and actually open order ride service now and go to the controller. And let's get in here and let me just put a breakpoint here, right here before our user call. So just a really brief overview, when a new request comes in for a car, we're going to look up the user by their GUID that comes as part of the packet. And then we are going to create a command, and then we're going to publish an event, essentially a ride created event. And that ride created event, based on that publishing other services, essentially the driver location will respond to that event accordingly. So I have the breakpoint here. So let me go back to our Swagger here, and I'm just going to minimize this for a second. And so let me close out some of this stuff. I'm sorry. All right. So let's just go back to the Ty dashboard, and let's go to the order ride service, and we're going to go to the HTTP binding here, and then same thing, we'll go to Swagger. And all right, so what we're going to do is we're going to post a test packet in. So we're going to come in here and try this out. So I just have a sample sample code here. Let me just go get that. And this is me ordering a car from locations in New York where I used to live in the past. So I will come in here. I will execute this packet. And what you'll see now is that my Visual Studio Code is flashing and we're debugging. So now we are here. We've stopped, so we've responded to the HTTP post, right? That to order the ride. And now what we're going to do is we're going to sort of step into this code. As we talk, so the first example here is we're going to do that direct method invoking, right? So how we have this set up here is that we know that we need to talk to user service and we need to pass it a user ID. So we're going to create this request. It is a GET request, and then we're going to use the Dapper client to sort of invoke it. And so I'm just going to F10 through this. And then what we'll see now is, we should have caught on. Unfortunately, something did not run. Let me go back to Swagger here. Where's my user service? Oh, the demo gods are not happy today. Okay, so let's just detach from that because we are running close to the end of time. So let me just. All right, so let's head back here for a second, right? So so I did mention a few other things, right? So let me just see if I got anything in Redis, right? So no. So all right, so let's do this. Let's try it one more time. Let's try it without the debuggers attached. Just so let's try executing this again. And okay, so I actually am seeing that the event is being created. And okay, so this time it's working and it's not, so we'll go, if you look through the debug screen here, what you'll see is we're getting sort of a gathered output from the ride controller. So we did actually get a ride ordered, and then the driver service responded. So let me go back to Redis now and for some, there we go. Yeah, that's what I was looking for. Okay, so as you can see here in Redis, so this is Redis Commander is a free tool you can run. It's an NPM package that you can use to sort of to look at your local store, or I guess any server, any Redis server. As you can see here, all the events, these items here are the different events that we defined. The ride created event. Here are our state stores, these hashtags here. As the system was saving the different items, we were persisting it, essentially using a GUID as the key. Yes, as you can see, without any sort of Redis native Redis integration, we're able to use Redis as a store, as both a pub sub and as a event bus. So seeing how this happened was, unfortunately, debugger was a little less eventful than I had hoped. But let's do something really quick that hopefully will show some more of the power of this. So let me just stop. I'm just going to stop this this execution of all those services. And as you can see, when you finish that process, we move over, and you'll see the Docker containers are starting to sort of disappear. They'll start disappearing in a sec. Okay, and while that's happening, I am going to come in here and I'm going to go to that thai.yaml file that we talked about earlier. And all right, yeah, and let me just, so I just wanted to, I'm just going to, so here really quick, I am going to just turn on another extension. those of you, if you've ever worked, and this kind of goes into that idea of telemetry or centralized telemetry. SEC is a tool written by the same team that builds Serilog, which is a very popular logging framework in the .NET ecosystem. And SEC is a great tool for sort of aggregating logs. And so I'm just going to turn it on really quick, and I'm just going to run this again. And like you see, like I mentioned, all those containers disappeared, and now they're all going to come back. So while that's happening, let me just go back to my browser and let me kill some of this stuff. Okay, we're coming in here. So as you can see, because this is the first time we're running SEC, it's actually doing a Docker, it's pulling the image. And you know what? While this is loading, because this might take another minute, maybe this might be a good time to start any Q&A.
Hey, Vincent. Pedro says, great talk. Is the source code you wrote in a public repo? Yes.
So the source code, let me just go back to my deck really quick. Right. So, okay, while that's running, let me just, yeah, so the source code, so it will be here. And I'm sure, it's in the deck. This code will be updated, is up to date, is what I'm running right now. I probably will want to I might be throwing a Blazor front end in front of it just to make that initial entry point easier, but the source code is definitely there. All the configuration files, probably some of that Cosmos stuff will probably be in there later tonight or tomorrow, but everything else running is there now. Also in this deck, you'll find a bunch of links, all the links to Dapper, to Project Ty, some more detailed descriptions about the sidecar pattern, as well as the actor model, which I really glazed over, but apparently, I lost a little track of time myself. So I'm glad we didn't go there. Thanks for the question.
That's it.
That's it. Okay. All right. Great. So we have 3 minutes. So let me run right back here. So this is up and running now. So same thing as before. Let's go back to, let me find the right browser here. Okay. So as I mentioned earlier, that now everything's been running on different ports, but the dashboard is a constant. So the Ty dashboard is a constant. So as you can see here, now we added SEC. Now Ty is managing an instance of SEC as well. So one thing I want to sort of point out, as far as the local development goes, as you can see, you can also define containers to run. And there's some great examples at the Project Ty's sample pages, links in the slides. There's a great example of a sort of cross, a bunch of .NET services and then one Node.js service running in a container. Right? So there's a lot of great examples. I also very much recommend that people go and look at some of these samples in the Dapper GitHub repository. There's a great example is a distributed calculator, obviously super contrived because it's 4 different languages, one language for adding and .NET for division and JavaScript for multiplication, and a React front end. So right, so it's kind of but it does kind of really give a good distributed, a good home project might be to take that project and then introduce Ty into it, and that might be a little fun project. But what I wanted to show really quick was SEC. And we're talking about, so SEC is this great front end for structured logging, right? So I use this on a few of my projects at my client, the ones that are not using App Insights, essentially. I end up using this product a lot. And, in our case, our systems are talking to it directly through TCP or through the telemetry. This tool could also be used to read files or, read files in certain formats, especially if you use Serilog. It kind of really goes hand in hand. But as you can see here, by just adding those 2 lines in the YAML, I now have a centralized log repository for all my microservices here in this solution. And that's, goes back to some of those challenges in the very beginning of the slide deck, right? Being able to diagnose items. And, there's a lot of patterns we didn't even get to today, talking about, how do you correlation, how do you tie sort of requests between services, and how, to sort of trace items from beginning to end. In our example here would probably be like the ride ID that gets generated. Yeah, so I think it's, so again, Project Tie super powerful, and Dapper super powerful. I am at my time, and if there are no other questions, I just wanted to say thank you for everyone who showed up today. Remember, there's a lot of great talks still coming in the next 2 days. Please make sure to sign up. And, also, follow us at Cognizant Softvision. If you can find us on LinkedIn, on YouTube. There's a lot of great material on YouTube as well that we provided over the year. And, thank you again for spending the hour with me. And, I hope inspired some people to start developing microservices in this manner. So thank you very much.